Yeah.
Saying hi to YouTube. Right, if it's 90%. Yeah, 90%, yeah.
Okie dokie. Y'all ready?
Let's go.
Let's go. I bet y'all have never seen one of these before.
What's this? Never seen it.
The chaos, right?
Oh my gosh, what is that?
Chaos ensues. Who knows the refrigeration cycle like really good? Pretty good. Good.
Yeah.
Hanson, how come you're not raising your hand? You want to come explain it?
Oh, I don't.
Alright, before you guys go out on internship, you need to know this. Come and run the most prestigious school out there, you gotta know this. Y'all have seen this before a gazillion times probably, right? Mr. Lamb beats it up for sure, I know.
Oh, sure.
Mr. Davis does too. Y'all all had Lamb and Davis for
That was a
applications.
long time ago. If you didn't know it, like lamps, if you didn't know it, we went over it like 2 weeks straight. You would call on us all for like 30 straight days. Every single day.
Hey, before we bust into this, do you guys know how to look at a compressor and tell the difference between a scroll and a reset?
Kind of.
Okay.
Not right, you would.
Well, let's do that first. This would be a scroll. Discharge is out the top, suction on the bottom. Y'all remember how the scroll works? You got the stationary scroll, you got the orbiting scroll off center. So your scroll set is up here, and then your motor windings are down here. So suction gas comes in, cools off the motor windings, gets sucked up into the scroll set, compressed, sent out the discharge line, right? So scrolls discharge out the top. That'll be the small line, right? The discharge line is the small line, suction line is the big line. So if the little line's hooked up top, it's a scroll. If you look at it from the top, it's round and it's tall compared to a reset. It's a lot taller. Discharges out the top. Which one's better, scroll or reset? Scroll. Scroll will always win. What makes a scroll better?
Well, it can handle liquids.
It can handle a little bit of liquid, right? Compliant scrolls. You guys know what compliant scroll means? Compliant? It means that if liquid comes in, then the scrolls will actually separate and centrifugal force or whatever get the liquid out, and then it seals back and it'll start pumping vapor again. So a lot of the old timers will be like, scrolls don't wear out, they wear in. You know, just the more they go, the more they go. But they'll still hate their life if you hit them with a bunch of liquid. You'll still wash the bearings out. You'll still wash the oil off the bearings and everything like that. So scrolls are better because how come?
They can handle a little
They can handle some liquid. What else? What makes a scroll better?
A little bit more efficient.
Hey, I didn't think anybody would get that one. They are more efficient than a reset. Because a reset, the piston, you'll always have top dead center loss because that piston can't come up and like kiss the valve plate. You can't come up all the way to the valve plate. It's going to stop just a little bit before the valves, right? So there's always a little bit of loss on a reset. So there's that top dead center loss. So yeah, there's no top dead center loss. What?
Was that thing I was messing with in commercial? We put a paper in and then scroll compressor inside of it.
That was a screw.
Or a screw.
That was a screw. Yeah, that was the male and female rotors. One other benefit of a scroll is that they're quiet. Like recips are loud and noisy.
They're quiet-ish.
They're quieter than a recip. So comparing a scroll to a recip, things that make a recip better. Y'all said it can handle some liquid. There's no top dead center loss. And what was the last thing I just said?
They're quieter.
They're quieter. And then, if you look at a recip, and this is residential class, so we're talking hermetic reset. Hey, what does the word hermetic mean?
Sealed.
Sealed, welded up, can't, right? So if it's semi-hermetic, you can unbolt it. Everything's flanged, gasketed, whatever, you can unbolt it, take it apart. If it's hermetic, it's welded up. But recip, short and squatty, and then discharges out the bottom, and then suction will be up here on top. Because on a recip, your pistons are actually down here. That's a piston, whatever. Pistons are down here doing work. Your motor's up here. Suction gas comes in, cools the motor off, gets drawn down here, compressed, sent out the discharge line. They top view, they're oval. Alright, so if you get out there and you find a faulty compressor, you can call the manufacturer. If this is a train unit, you can call train and get their compressor, but if it's got a Copeland scroll in it, like I would just call your favorite supply house. United Refrigeration has a lot of compressors if you're in the Tulsa area. Like you can do United, Johnstone, any of those people like that. And anyway, just grab a compressor and go. You guys know, check all your parts, right? So if you go buy, especially on a compressor, you don't want to do a 4-hour compressor change out just to realize you got the wrong compressor in there. Been there. Like a 480 volt compressor will not run on 208, unfortunately.
It'd be cool if it did.
Huh?
I said it'd be cool if it did.
It'd be cool if it did, man. And if you take that part out of the box, it's now yours. So you got to check it before you do anything. Check it before you leave the supply house. Let's talk about, since we're talking compressors real quick, you guys want to remember the IPR valve that's inside the compressor, internal pressure relief valve? That sound, y'all heard that sound? We did that out here, right? Yeah. IPR valve. Every compressor, if it's a hermetic compressor, if it's hermetic, it will have an IPR valve so that if it builds up too much head pressure, it'll start taking some of that head pressure, that discharge pressure. And so like on a scroll, if it's building up too much discharge pressure up in the scroll set, it'll pop open a valve inside the compressor and it starts dumping discharge. You like the sound effect? Starts dumping discharge gas back into the crankcase, into the suction. So if you were to throw your set of gauges on a compressor that the IPR valve is leaking by, or if it was open, like what are your gauges gonna, what are your pressure gonna look like?
Whack.
Like what?
Whack.
Whack, I agree. Head pressure is gonna be normal, low, or high?
Low.
Probably, because I'm dumping discharge gas into the crankcase, into the suction, right? So what's your suction pressure gonna look like?
Very high.
It's gonna be high. And it's got that distinct sound. What's your amp draw gonna look like?
High.
It ain't pumping much. So it'll be low. It'll look like the valves are knocked out of the compressor. Alright. Discharge line. Hanson, what's the state of the refrigerant right here? You didn't raise your hand a while ago, man.
Great question.
Discharge. Jesus.
High temperature.
High temperature, high pressure,
Yes.
superheated vapor.
Or vapor.
Gas, vapor, yeah. High pressure, high temperature, superheated vapor. Where did this superheat come from? Anybody?
Compressor.
Both, yeah. So we superheated in the evaporator, and it comes in as a nice cool suction gas. What is superheat? What's the definition of superheat?
Any heat added to the vapor.
All right, any heat added to a vapor. So if I got vapor refrigerant coming back here, and its first job is to cool down this compressor, the motor windings, it's picking heat up off of that motor windings and sticking it in the refrigerant. Nice cold suction gas, gets warmed up, we put the heat from the winding into the refrigerant, so we're heating up that vapor refrigerant, that's superheat, right? No problem. Everybody cool with superheat? Heat added to a vapor refrigerant above its saturation. Alright. And then it drops into the condenser. What's the first thing we got to do with this superheated vapor? First thing is to de-superheat it. Not a real common word, but yeah, it'll de-superheat. So we're going to pull some of that heat off of the vapor. And then, anybody have Mr. King for applications or anything? Anyone have Mr. King explain the refrigeration circuit to you? Well, he does a really good job. He says you put on your rain gear and you're walking inside this line right here. Like in here it's hot, like hotter than hell, right? What's a normal discharge line temperature? Like if I were to clamp on that, like what's a normal discharge line temperature?
110 degrees.
Okay, 150. What's the maximum discharge line temperature? Anybody remember that?
Is it 250?
250. Because if this is 250, if I clamp on and that's 250, remember the rule to figure your oil temperature? You add 75 to it, right? Like you clamp on like 6 inches from the compressor, add 75 to it, and that's your oil temperature.
I thought the oil transfer carbon at 300.
300 is critical, 325 is game over. Yes.
275 to 300.
Yes, and you will read everything, and it depends on people's opinions and everything else.
Say 275?
Yeah. So 200 would be the maximum here, because you add 75 to it. That makes it 275. 300 starts breaking down. 325, like it's done.
Wait, so a normal temperature you would see there would be what?
Like 150 or less.
Okay.
If my discharge line is smoking hot, 200 degrees, oil's at 275, what are some things that would make this compressor run really hot?
Underloaded.
Who said low charge? That is the number one reason. The number one reason is an undercharge. What's keeping this compressor cool?
Suction gas.
Refrigerant, suction gas, right? So if you have an undercharge, compressor's gonna get smoking hot, and you're gonna know it. Alright, it de-superheats, and then pretty soon you start running into this little rain shower, right? Start getting these little drops of liquid. And then it starts raining more and more and more to the point that it hits that saturation point, right? It's starting to condense the refrigerant. So you guys understand the whole reason why we compress the refrigerant? What is the purpose of the compressor? There's $1 million question. What's the purpose of the compressor?
To move refrigerant.
To move refrigerant, yeah.
Add superheat.
And that's the big thing. We want to get the temperature of this refrigerant above the ambient temperature. If it's 100 degrees outside, right? I want to take that outdoor air of 100 degrees and I want to use it, I want to blow it across that coil and use this 100-degree air to condense my refrigerant. So to be able to do that, I'm going to warm it up above ambient conditions, basically. So now it's warmed up to 150, 170 degrees, whatever it is. It drops in here, it de-superheats. It starts hitting that condensing temperature, it gets close to it, we start getting little droplets, then we get more. Then you hit the rain shower, and it's just raining in this son of a bitch, right? Just blasting, right? All the way till you hit that saturation point, like right there. Let's just say it's right there.
2/3.
Is that what y'all been taught? 2/3?
So right there it's 100% liquid?
Yep, that's where it gave up, and it became completely saturated. What's the definition of saturation?
Where it's both gas and liquid?
Saturation?
Oh.
No, it's a.
Saturation is when one object is holding all of another that it can. So whenever it starts to condense and it goes to a liquid, when it's 99.99999% liquid, but when it finally gives up and goes saturated, goes 100% liquid, like that saturation, it's holding all the liquid that it possibly can. And then it finally gives up and it's like, what's up?
So when you said de-superheats, that's just saying before it even gets into the condenser, the outside air is blown across it and taking away the heat.
Yeah, some of that superheated vapor, it's
Like 100.
and Hey, you guys have probably heard people say that it's de-superheating down the discharge line, right? And it does. Technically, it de-superheats maybe a few degrees down the discharge line. But when it enters the coil and we're blowing that air across it, we're blowing 1200 CFM or whatever air across it, that's when it's really going to de-superheat. And then it'll really start to try to condense, hit the saturation temperature. Saturation, like, it's holding all it can, right?
Reject heat, absorb heat.
Reject heat in the condenser, absorb heat in the evaporator. Saturation. So if Hansen is so full of crap, one might say that he is saturated with crap. I'm just picking on you today, man. I'm so sorry. I feel kind of bad. Saturation. It's holding all that it can before it just turns into crap. It's holding so much crap that it finally turns into crap, right? It's holding so much liquid that it finally just turns into liquid. What'd you learn at school today?
I learned that I'm a piece of crap.
I learned that Trevor Hansen's full of.
Yeah, he's saturated. Alright. Do you guys understand? We're right here where it actually condenses at, that saturation point. That is the only place where the PT relationship exists. That's it. When you hook up a high side gauge, and if it's 410A, you're looking at the pink numbers on your gauges, that's what it's telling you. If it's pointing at 110 degrees, it's saying it turned into a liquid at 110 degrees, my high side. This is the only place that the PT relationship exists. And the same thing over here, when it evaporates, that's the only place. There's only two places that your pressure temperature relationship exists. Two. That's it. Saturation of vapor, saturation of liquid. Huh? Because, yeah, if you hook a high side gauge right there, or 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 right there, this should all be the exact same pressure. Close to. It should be the exact same pressure. If you're on a package unit, the tap is on the discharge line. If you're on a split system, the tap is on the liquid line. But that head pressure should be the exact same, because that head pressure is only telling you what temperature am I condensing at. Cool? Alright, so it condensed. It gave up, saturated, it became a liquid. It condensed. What are we doing for the remaining of this condenser?
You're 100% liquid, it's subcooling.
Right? So if we condensed at 120 degrees or whatever, if it's 100 degrees outside, I'm 20 degrees above that, I got a 20 degree condenser TD. Can I still pull some heat out of that liquid though? It's 120 degrees going through the condenser, but I'm pulling 100 degree air across it. There's going to be a heat transfer happen, right? Hot's going to go to the cooler, so I can still cool this down. What's it called anytime you cool a liquid refrigerant? So this last bit right here is all subcooling.
And we keep subcooling from the moving device, don't we?
A little bit. So see, that's the thing. Like,
It's the same thing as the discharge line.
it's the same thing as the discharge line. It's minimal. It's the same thing as this suction line. Like, you may pick up some heat in that suction line, especially if it's in a 140 degree attic or whatever. Like, you may pick up a few degrees. It's minimal. It should be minimal. So subcooling. So then let's say I clamp on my liquid line right there, and I read 110 degrees. Based off of that information, what is my subcooling?
10 degrees.
10 degrees. High side converted, PT relationship right there. 120 is my condensing temperature. I condensed at 120 degrees. And it's 110 leaving. I clamped on and got it right there. So the difference between my liquid line temperature and my saturation temperature, the difference between the two is 10 degrees. I got 10 degrees of subcooling. Okay? And then it leaves the condenser, goes up the liquid line, goes inside, hits this girl, right? Metering device. Hey, here's a bonus question. What's the line called after the metering device?
Expansion line.
Wow. Who'd y'all have?
Lamps.
I'm impressed.
I had YouTube videos.
And Davis.
Expansion line. That's pretty good. Usually I can hang people up on that one. It's the expansion line. Did y'all talk about throttling?
Yes.
What's the definition of throttling?
Boiling off a portion of liquid.
To cool the remaining liquid, right? So you're gonna boil some of it off, evaporate some of it, so that it'll cool the remaining. It's the exact same thing as when you get out of a shower and you got water all over you. You get cold, right? Because the water is evaporating off of you, and when it evaporates off, it cools the remaining. Make sense?
Mm-hmm.
So we're boiling, we're evaporating at 40 degrees, but, alright. Throttling, boiling off some of it. We've got a 75-25 mixture here, right? 75% is it, which one's liquid? 75% what? Liquid. 75% liquid, 25% vapor. Enters the evaporator. Let's say that the house, my return air is 75 degrees. My refrigerant enters into the evaporator at a 75-25 mixture. I'm putting heat into the refrigerant, and so it begins to evaporate, it begins to boil, and it starts turning into a vapor. And so right here I've got a 50-50, and then right here I'm 25-75, and then it hits that same saturation point, so you can saturate back over to a vapor. You can saturate liquid, you can saturate vapor. So right here, it goes right back, and it hits its saturation point. If I look at my low side gauge, if I look at the pink number, that's where the PT relationship exists at, right there. So let's say that it is 43 degrees. Looking at my low side gauge, converted, 43 degrees. I can do evaporator TD, right? 75 minus 43. Return air minus low side converted. So I've got a 32 degree evaporator TD. We'll go there, but my refrigerant evaporated at 43 degrees. But I'm pulling 75 degree air across that coil. So even though the refrigerant went 100% vapor right there, it's 43 degree vapor. So 75 degree air, we're going to start putting some of that heat into that refrigerant, right? We're going to have a heat transfer. Anytime you have one object that's warmer than another, we're going to put some of that heat into this refrigerant. Is everybody good? I feel like I'm, all right. If I'm putting heat into a vapor refrigerant, everybody agree that it's vapor after the saturation point, right?
Yes.
100% vapor. That's the evaporator's job, is to evaporate, turn it into a vapor. So if I evaporate it at 43 degrees, but yet I'm still pulling 75 degree air across here, I'm going to put some heat into that. What's it called when you put heat into a vapor?
Superheat.
Superheat. So this is where all my superheat happens at. So let's say I clamp on the suction line. I clamp on right there, 55 degrees. What's my superheat? 12. I evaporated, I looked at my low side gauge, converted it, used the pink numbers, used the green numbers, whatever refrigerant I'm messing with. It's 43 degrees. Clamp on the suction line, it's 55. That's a 12 degree difference. I got 12 degrees superheat. Everybody good with the refrigeration circuit?
It's a high or low pressure.
Low
superheated
pressure, low
vapor.
temperature, superheated vapor. Yeah. Coming down the suction line. Low pressure, low temperature, superheated vapor. You guys see vapor, superheated vapor? Compressor is a vapor pump, right? Don't like to pump liquid. It needs to be a vapor pump. What else?
So subcooling is subcooling is line minus gauge, or
We're getting ready to do that.
okay. It's just a liquid pressure.
you're gonna troubleshoot a refrigeration circuit, there's 4 readings you must have. Like 4 is the bare minimum. If I can't figure out what those 4, then I'll dig deeper. But 99.9% of the time, you can find it with 4 readings. The first one is condenser TD.
Evaporator TD.
Damn right. Y'all done this before, huh?
There's some lamps scarred in our brains.
Good. And subcooling. Before we start talking formulas and getting all nerdy, like let's have some regular folk conversation here real quick. You guys know like we're the best of the best, right? We're the nerds, right? You guys know how hard it is being me? I'm just kidding. What's it?
Oh, how cold does that freezer in Capstone get?
That one in Mr. Davis's down there?
Yeah.
That negative 100 Fahrenheit.
Oh.
That cascade system.
They freeze lower.
Yeah.
The dead bodies that I murdered.
Can we play with it one day?
Absolutely.
Can we walk in there when it's negative 100?
It's like a medical chest freezer thing. You open up, put stuff in.
Like smoke around.
Can we put Noah in it?
I volunteer to go in it.
Hey, like
For a second.
when I give tours and everything, like there were some 8th graders that came through one day and they're like, "Oh, I want to touch it." I'm like, this like the like sticking your tongue to the pole or whatever ain't got nothing on that thing. Like if you touch something in there, like you're leaving some DNA behind. I promise you. Like it will stick to you bad.
So
Noah.
can we put somebody in there?
No.
Why not? What, okay. What if we close on that?
Yeah, what if we
Put
rather
lasers
in
in
saran
there.
wrap?
Why can't we just put watermelons in it or bananas and stuff like
Because
that?
I want to see what happens if we put a human in there.
Could you eat it?
I'll put
No.
Can we throw the watermelon?
Yes. That's what we do. Thank you. See, we freeze watermelons. I shouldn't have the camera on right now. And throw them off the roof.
Oh, yeah.
I'm down.
Yeah,
And
we
they
have
shatter like glass.
Let's do it.
So hear me out. Theoretically,
Okay.
if we put someone in there, disc style, they will come back.
They shatter like glass.
Yeah.
Well, they shatter like glass.
Might make it superhero.
Alright, let's do some nerdy stuff.
Messing with you.
You have to edit
No,
that.
let's not do nerdy stuff. Let's talk plain people, normal conversation stuff.
Alright, man.
If you're trying to explain condenser TD to a homeowner, like what does condenser TD tell you? Does anybody know? Why do we even check condenser TD?
It checks efficiency.
Kinda. What?
It dictates your head pressure.
Alright. So all it really does,
See if it's equals to 30.
all it tells you is my head pressure, normal, low, or high. That's all it tells you. So if you're gonna call me or you're gonna hung up on one, it's running high head pressure. I'm like, well, what's your condenser TD? So now we gotta talk about normal condenser TDs and stuff too. We'll get there.
Yep.
Y'all remember what a normal condenser TD should
It's like 20, 25 degrees, depending on the Seer rating in the unit.
Yeah. 20 or 30. I've never seen 25. Really? I haven't.
I got 25 on my lab book.
Do you?
Yeah.
True. We're gonna come back and do the formulas. We'll come back to condenser TD. Let's just talk normal people talk. Condenser TD, is my head pressure okay? Or is it high, low, whatever? So if condenser TD tells me about my head pressure, what do you think evaporator TD is gonna tell me?
Low side.
Is my suction normal, low, or high? That's all it tells you. is my suction pressure normal, low, or high? So if you're gonna be able to say like, hey, I've got low suction, low superheat, or I've got low suction, high superheat, or I've got normal suction, whatever. All it tells you is my evaporating temperature okay? Is my condensing temperature okay? You guys realize like I get zero dams about pressure. The only reason why we want pressure is because we want the temperature. We want to convert it. That's it. Pressures mean nothing. Like we want the temperatures. So
Are they like proportional to each other? So like.
yeah, if the head pressure goes up, suction pressure will usually go up. Like not always, but
Well, like if the
pretty much.
evaporator TD is high, was the suction gonna be high?
Then the head pressure may track that a little bit, but head pressure is going to be dictated by outdoor conditions. Suction pressure will be dictated by indoor conditions, but they do track each other slightly. Alright, still just talking normal folk talk. What does superheat tell you?
Whether the evaporator is starved or full. Or flooded. Flooded is the word, yes.
Yes.
Sorry.
Is evaporator normal, starved, or flooded? I'm telling you guys all this because this is how we're going to talk from here on out. Normal, starved, flooded. You say, I got a flooded evaporator. If you have a flooded evaporator and a flooded condenser, that's an overcharge. You got too much liquid in the evaporator, got too much liquid in the condenser. So if I'm flooded, that's an overcharge. If I'm starved, where's the refrigerant at? Yeah. It's in the big blue recovery tank in the sky or something that leaked out, right? So that's what we're gonna do. If I'm normal and flooded or whatever. So if superheat tells you about the evaporator, what about subcooling? Condenser. Is the condenser normal, starved, or flooded? Alright, sloppy story. Subcooling. Is my condenser normal, starved, or flooded? Got all this? Start back over at the top. I want to figure condenser TD. What's my formula? I need to know the outdoor air temperature.
ODA and your
High side pressure converted.
High side converted. So high side converted should be higher, right? So to find condenser TD, I'm going to go high pressure converted to temperature minus outdoor air. These are great notes. Evaporator TD.
Low pressure.
Now I'm looking at the low side converted, and then whatever load is on that coil. So on an evaporator, return air. But so let's go. Return air is going to be warmer because we're putting that heat into the refrigerant. So it's going to be return air minus low pressure converted temperature. Return air minus low pressure converted temperature. Everybody knew that?
Yeah.
It's kind of a refresher, but you knew it at one point. Hopefully you knew it still. Alright. Let me show you guys what I do. It works for me. See if it works for you. Like in my head, I already know what I'm looking for. As soon as I screw my gauges on, I already know what I'm looking for. I don't put my gauges on and then start running formulas or doing the math. I do it flip-flop. So if I'm outside and I'm like, I'm a human thermometer because I've taken temperature so many times. But this class, I nailed the outdoor temperature yesterday. I was like about 84. You're dang right, I nailed that temperature. So I do it backwards. If it's 84 degrees outside and I'm looking for a 20-degree condenser TD, I go 84 Plus I'm looking for 20-degree condenser TD, so that'd be 104. So as soon as I screw my high side gauge on and I look at it, I'm looking for 104 degrees. If it's higher than that, I got high head pressure. If it's lower than that, I got low head pressure. Make sense? I already know what I'm looking for before I screw it on. That's the way I do it in my head. I go outdoor air plus 20, boom, that's what I'm looking for. And then I go indoor air, return air, minus 30, because I'm really looking, say I'm looking for a 30-degree evaporator TD. So if it's 72, minus 30 would be 42. If it's 72 in the house, minus 30, my expected evaporator TD, I'm looking for a 42-degree evaporator. So as soon as I screw the low side gauge on, I'm looking for 42 degrees. If it's lower than that, I got low suction. If it's higher than that, I got high suction. Pretty easy? Pretty easy? Superheat is suction line temperature minus low pressure converted. I'm going to clamp on the suction line. I'm going to take the pink number off the gauges or the green number or whatever refrigerant we're messing with. Because everybody realize that your gauges have a PT chart built into them. You don't have to use a PT chart unless you're using your gauges for some oddball refrigerant like 134A or something like that.
And U22.
Yeah, nobody uses that crap.
Except us.
I guess so. I like 421A.
What can you say about 407C?
Yes.
407, I've used it on a lot of medium temp stuff like chillers. If I'm retroing a medium temp like a chiller, I'll use 407C. That's just my opinion. And then on high temp stuff, residential, like air to air high temp stuff, I usually do 421A.
How often do you mess with mercury in the refrigerator?
With what?
Mercury?
Never. Ever.
Suction line.
This is suction line temperature. I'm abbreviating.
Okay.
Is everybody cool with superheat? It's heat added to a vapor. So subcooling. Remember, I'm gonna compress the refrigerant, and then I'm gonna de-superheat it, all that groovy stuff, and I'm gonna take my high side pressure, head pressure, convert it to temperature, minus outdoor air. Man, I was still thinking
Liquid
condenser
line
TD.
temperature.
I'm so sorry. Liquid line temperature. I was still thinking condenser TD, my fault. High pressure converted temperature. So what temperature did I condense at? And what temperature is the refrigerant leaving the condenser? I condensed at this temperature, it's leaving the condenser at this temperature. What's the difference between the two? That's subcooling. Any heat removed from a liquid.
So you said a normal condenser temperature would be 20 or 30?
Yeah, well, that's what we're going to do next.
Okay,
What dictates our head pressure? Outdoor conditions,
yes.
condition of the outdoor coil. If it's dirty, it's going to drive up the head pressure. If it's raining outside, it's going to lower our head pressure, right? You got a wet coil. Let me see, maybe I'll make a chart. I was going to try to write it up here, I'm getting kind of full. Hopefully y'all got room. On condenser TD, if it's 10 Seer or less, like we're talking old girls. If it's R22, I'm not even going to say that. You will not find a 410A 10 Seer machine. If it's 410A, then it's going to be 12, 13 Seer or more. If it's 10 Seer, it'll be a 30-degree condenser TD. If it's 12, 13 Seer or higher, 20-degree condenser TD. So yeah, whoever's throwing out that 25, like I'll fight them. I've never seen 25. It's always either 20 or 30.
My treatment was on
What's the highest Seer they're making now? 'Cause
20?
I heard like 29 the other day, and I was like,
Yeah, on some of the inverter stuff and everything, it gets wild.
that's what my family friends are getting, because their house burned down. They're like, yeah, we're getting best we can get spray foam insulation, electric heat. He's an electrician, so he makes good money.
Does he need a bid?
No, he's gonna do it all himself and have me help him.
You guys know, how do we go from 10 Seer to 13 Seer? What's the big difference between a 10 Seer unit and a 13 Seer unit, besides the refrigerant? You could totally get a 13 Seer R22 unit back in the day. Easy. Yeah, how did they get the efficiency up? What's the difference between those units?
Condenser coil size.
Yep. Surface area on the coil. Bigger coil. Either double stacked coils or big monstrous tall coils. 4-ton units that hold like 16 pounds of refrigerant kind of coils, like big monster coils. Big evaporator coils. Alright. Evaporator TD. On 10 Seer or less, 30 degrees again, same as your condenser. So I'm looking for 30 above outdoor air and 30 below indoor air. And hey guys, evaporator TD will like get you in the ballpark, but we're only talking about sensible heat right now. We're not talking about any of the humidity. And we all know that the latent load, the humidity, is a big load on that evaporator, right? So if the humidity in the home goes up, this may not hold true. If we start sticking a bunch of humidity, a bunch of big load on this evaporator, it's going to increase the evaporator temperature, which is going to bring it closer to the return air temperature. So with a big load, I run higher suction pressure and a smaller evaporator TD. So instead of being 30, maybe it's only 25 because they're closer together because I'm putting so much heat into the refrigerant, getting it closer to the return air temperature. Sticking all the heat in the refrigerant, right? 13 Seer and above, or I did 12 Seer. 12 Seer is not real common. 13 Seer was way more common. 25 to 30. Because it's a bigger evaporator. It can absorb more heat, and so it brings the suction pressure up closer to return air temperature. So that's where the 25 comes from. It gets a little closer to the evaporating temperature. Have I lost anybody? Is everybody cool?
Easy word.
Huh?
Easy word.
Easy stuff? Good. Alright. Everybody got that so far? Boom. Condenser TD, evaporator TD, expected numbers. What do you expect to see for a superheat? It's a loaded that's a loaded question.
8 to 12.
Maybe. How about 0?
Well,
Maybe. How about 1? Probably. How about 30? Maybe.
3.
Yeah. Alright, expected numbers. What if it has an expansion valve on it? What does a TXV maintain?
Superheat.
It maintains superheat. How much superheat does a TXV try to maintain?
10.
10?
11.
11?
Whatever you said.
Yeah.
12? Let's just go 8 to 12. Guys, there's some stuff out there the TXV will be undersized or choked down a little bit, where they'll run a higher superheat. They'll starve the evaporator. Matter of fact, Train, like 5-6 years ago, I'm going to trash talk them a little bit, but this is back when I was selling American Standard. But on the 5-ton evaporators, they were having huge problems with water blowing off of the coil. And so water, especially on the horizontal stuff, man, we did a horizontal 5-ton, and it was blowing water off of the coil like crazy. Static pressure was good, everything was good. Ductwork was legit, static pressure was good. It was still blow water off of this coil. And so they put this big, like, metal flap in there, so any water that flies off hits the big flap and then rolls back down. I mean, it's like this long. Have you guys seen a 5-ton evaporator lately? They're 36 inches tall. Like, they're freaking huge, man. And so back in my day, a 5-ton evaporator was only like 20 inches tall or whatever, you know. Now they're like, now a 5-ton evaporator is like 36 inches tall. Oh yeah, so this Train, so that was their fix for it, was they were having problems with water blowing off the coil. Their fix for it was to put an undersized TXV on the machine. So they would choke the coil, choke the evaporator, starve the evaporator. Because basically, every part that you have liquid refrigerant in, especially when you have the liquid refrigerant in the tubes, that's the part that's doing your dehumidification. That's the part that's all the moisture is going to stick to. And so they just choked and starved the evaporator. And so on those, they even had a sticker. You had to take the panels off. Like, I thought I had a bad TXV. I had 31 degrees of superheat, and subcooling was fine, but still, I checked everything. Checked for a return air leak, checked the actual temperature split and everything. Everything was good. So I was like, I'm going to add some refrigerant to it. Because every once in a while, like, your subcooling will be fine, but superheat was through the roof, starved. Every once in a while, like, you can just put some refrigerant in it, and subcooling will stay the same-ish, but it'll drop your superheat down where you need it. So I put like 2 or 3 pounds in it. Subcooling went through the roof. Superheat didn't change. So I was going to change the TXV. Long story short, take the panel off. And inside there's a sticker that says it is normal for this evaporator to run 25 to 30 degrees of superheat. Like, and it just got my attention, and I started researching and everything. But that's what happened. They were having problems with water blowing off the coil. They put an undersized TXV on it. They choked it down. And so that TXV on that 5-ton Train American Standard was designed to maintain 30 degrees of superheat. It was pretty wild. That's crazy, right?
So that's why you said it could be there.
Could be. Here's the next one. What if it's a fixed bore?
Yeah, you lost me there.
You're gonna have to find the chart for whatever brand of.
There you go. And guys, and every time you charge it off the manufacturer's chart. These are rules of thumb for mismatch equipment and everything else. Charge it off the manufacturer's chart, whatever they say. You guys remember fixed bore metering devices like pistons, like flow? I call them flow raters. That's the name brand of it. You guys remember how a piston? You remember all that good stuff? Fixed orifice. Yeah.
Oh yeah.
I mean, it's coming
I
back.
can't forget
The little brass.
It's got a hole in it, right? It'll say like number
Grooves
52.
across the top.
It does have grooves. When we start talking heat pumps, a piston, whenever it seats, like refrigerant's flowing this way, it's forced through the middle and it meters. When it comes this way, it unseats and it flows around those grooves so that it doesn't meter. So, do you guys understand that a fixed bore metering device is just a hole? Like, it is a dumb hole. That's it. So if I increase how much refrigerant is going to that hole, it's going to increase its output, right? If I raise the head pressure, it's going to have more flowing through it. If I lower the head pressure, it's going to have less flowing through it. Does everybody agree with that? It's going to flow something proportional to what we give it. If we give it a high pressure on this side, we're going to get a lot out the other side. If we give it a low pressure on this side, we're going to get a little bit out this side. Makes perfect sense, right? It's just a hole.
Wait, is a fixed bore like only first semester when we call it cap 2?
Yep, cat tube is a fixed bore.
You can't change that at all. normal.
You can put a
Like,
TXV on
the
it.
TXV, you could, get your, wrench thing and
Yeah.
shift it a little bit, but.
If anybody goes to work for someone who says, man, I hate those TXVs, I'm gonna put a piston in it, like, run, in my opinion. TXV will always beat a piston. Pistons are stupid. There was some bad TXVs there for a while. It did get kind of dirty there for a while, but we're all right now. All right. We'll take a break in just a second. $1 million question. What is a normal superheat on a fixed bore metering device?
8 to 12.
Okay.
It doesn't care on matter.
Okay. Whatever the manufacturer says.
I was gonna say, don't you charge the system with like a captive based off of the head pressure not?
No, you charge a fixed bore by superheat.
Oh, you charge for.
Yeah. And then you charge a TXV by subcooling. So, remember, if I feed it a lot of refrigerant, it's going to feed a lot of refrigerant. If I feed it something low, it's going to feed something low. So, here's your answer, 0 to 30. Now I'm going to make a huge mistake, and I'm going to show you guys a redneck rule of thumb.
We like those.
Don't go out there charging everybody's unit based off of this, like, Boker said. No, this is a rule of thumb. It's just something else to put in your pocket to check the charge, okay? All right. Do y'all hear me? You're not going to go charge every unit like this, okay? Under normal conditions, 72, 74 degree house, 50, 55, 58, whatever percent humidity, normal-ish conditions. If the house is 80 and swampy, that won't work. Here you go. You can go 100 minus the outdoor air, and that should be your superheat. Don't take this to the bank. Don't go tell your mom about this. Don't tell anybody about this. This is a rule of thumb.
You said the outdoor air is 75 degrees?
25. It's hard to charge when it's 75 outside, though. It really needs to be like 80, 85, really, honestly. So, if it's 85 outside, what kind of superheat roughly are you looking for? 25? 15? 100 minus 85? I gotta think about that one.
You are kidding, man. It's because I'm his roommate. He's infecting me.
Redneck are just crazy rule of thumb. It's a rule of thumb only.
What do the conditions have to be exactly?
Like
inside and outside?
72, 74, 75. Normal humidity. If it's swampy in there and all the mail is sitting on the table all curled up and shit, it won't work. Have y'all ever been in a really
I like that curly paper.
That came from a real call I ran. The guy was like, look at my mail. Like, his mail was all curled up on the table.
You, sir, have humidity issues.
That was a 5-ton system on a 1,200 square foot house. One of the biggest, right? We did everything we could to derate that thing and still end up ripping it out, putting in 2 tons, maybe 2.5.
Was it a new yet?
Yeah, he was 2 years old. He made it 2 years, but he's one of those people who's like, I want that biggest. Like, I ran one of those calls for real, and we ripped it out. It took us a year. We messed with it all one summer, and then the next spring we ripped it out. But his papers were all curled up, like everything. All right, one more, then we'll take a break. Hey, yeah, one more. Normal subcooling. Let's just go 8 to 12-ish. And guys, plus or minus a little bit. Some of them's gonna call for 6, some of them are gonna call for 14.
long as it's not 0.
Yeah. Oh, I got a good question for you guys, and then we'll take a break. And then we're gonna come back in here, okay? If I have 0 degrees of superheat, how much liquid is making it back to the compressor?
A lot.
A lot.
A lot.
I would say it's
solid
solid copy.
If I have 0 degrees of superheat, how much liquid is making back to the compressor?
Whole column. All of it.
It'd be a saturated mixture, wouldn't it?
None.
I say a
None.
whole column.
Say something.
None.
0 degrees.
We don't know.
It's saturated.
You don't know. All you know is that it did not all the way convert to a vapor, because superheat is heat added to a vapor. So if you have 0 degrees of superheat, now that's all we're looking at, just there was no superheat. Don't even worry about the suction pressure low or anything, I'm just saying. No superheat. There's either one little droplet of liquid coming through every so often, or it's a 75-25 mixture blasting down through the suction line. You don't know. You really don't know. It was a loaded question. Let's take a break.
Huh? Y'all need to like get married or something.
What? Okay. I mean,
It's like, okay, I'm down.
will it be my college?
No.
I'm not in.
I'm not.
Trevor, you go for a shower?
Thank God.
So you see all those little kids that are here?
I'm sure I was like, no.
Yeah.
They were like 10
I was
years
in the
old.
lunchroom, I was going to fill up my drink before I got over here. And then there's these two younger girls, probably like 14, 15.
Wait, there's a torch, I mean.
They're probably like 14, 15.
Yeah.
And then I said, what are you guys doing here? And they were like, oh, we're doing this stuff.
If it's a TXV unit, you're gonna charge by subcooling, right?
Yes.
And if it's a fixed bore, superheat. Yeah. Superheat. Every time. Go to the manufacturer's charging chart. Whatever they say it should be, that's what you're gonna set it to. And guys, hey, and like I feel like I should scream this. Just because it's a TXV unit doesn't mean I'm only checking subcooling. If you do that, like you're doing this. You're only looking at half of the system. So even if it's a TXV unit, I'm gonna check subcooling and superheat. Even if I'm charging it, I'm gonna charge it by subcooling, but I'm still watching superheat. If it's a fixed bore, I'm gonna charge it by superheat, but that doesn't mean I'm gonna only hook up a low side gauge and charge it by superheat. I'm gonna watch condenser TD and subcooling and everything else. And the name of the game is to try to get the best of all 4 worlds. Condenser TD, evaporator TD, superheat, subcooling. I try to get the best of all worlds. There's gonna be plenty of times where you're like, man, I wanna add a little bit more refrigerant to this thing, but my head pressure's getting a little higher. You know, my condenser TD is climbing up on me or whatever. Does anyone mess with very many like replacement refrigerants, 427 and 22B and all that good stuff? 427, 22B, they all seem to run like a little bit high head pressure and a starved evaporator. So you're gonna be like, I need to add refrigerant to it. I need to flood this evaporator, but your head pressure will start getting up out of control. There are a handful of residential units that have EXVs on them, electronic expansion valve. Train did it, Ring did it. I think everybody probably did it on their high efficiency stuff. Yep.
Package units?
On what?
Package units?
For what?
Or don't they have EXPs?
Sometimes. Chillers for sure. Let's see here. Alright. Let me give you guys one of these.
What do you charge EXP with?
Just like a TXV, subcooling. It's an expansion valve.
What the hell does that mean?
Like,
Oh man, you cut yourself.
wow.
Oh, I know what's wrong. Indoor air temperature is above room temperature.
What?
What did you just say?
So it's above room temperature, it's hot in their house, that's the problem.
Indoor air is 78.
You must be old.
I keep my apartment at 69, dude.
I keep it at 65.
Trevor, don't even
Try
say
it.
Just like over 50 all the time.
Yeah.
Trevor's room is Max's house is like 40 degrees. Steve Jackson was trying to warm up to the steam this morning.
Bro.
Steam was not that cold. Yes.
I wouldn't take a shower just coming out of the
It
shower.
is.
No,
That's the only
I
bad
didn't
part.
even get in the shower, bro. I just turned the shower all the way to hot water, so then it gets a lot of steam going in the room. Dude, but it feels so good.
The only bad part about it is the first you get out of the shower, or you don't want to get out of bed in the morning, cause you're just like so nice and warm when you get out.
That's
Try
that's-
40 degrees with the fan on.
That's literally the first thing I do when I wake up.
That's how mad
Go
it's
turn the
like.
shower on and go run back in the bed until it's warmed up.
I don't use my heater during winter time, so it's whatever the temperature is.
It was set to 50 degrees and heat was on.
Yeah, might as well not even have a heater on.
Heard it boil it.
It's 30 degrees.
Inside.
Never put it in the unit, but it didn't want to heat or.
It was boiling.
Well, I guess.
Only our place. It was bad.
My house sucked.
I told you.
No.
I did a job one time where a guy didn't want air conditioning.
Really?
Yeah.
Why did they buy?
It should be Max's house.
What?
The guy didn't want air conditioning, he just wanted heat.
I did one where a guy, he was a concrete guy, and he built this concrete house out of blocks and everything. He was like, yeah, the blocks will keep it so cool. Like the R value of center blocks is like R2. Like it ain't gonna do much for you. And so I talked him into, I'm like, why don't we go ahead and pipe the refrigerant lines in while the house is being built, blah, blah, blah. Well, if you decide to add air conditioning, we can. And yeah, we added air conditioning.
God, it sucked. You didn't get the lines set.
What is that? Mr. Governor, have you ever been on scaffolding?
There was
before?
another one.
Yeah.
How do you like being, like, do you trust that stuff, or,
You just gotta kind of turn off your brain and just trust it, I
because
guess.
everything you move, the motion follows through and it
Yeah.
bounces you back?
It's kind of like being on a scissor lift or something. You know.
Scissor lifts, I don't like being way up there. It gets too wobbly.
Yeah. Strap off, like be safe. Hey, for real deal, I had a student last summer go on an internship, and they wanted her to put this ladder up in an elevator. And they're like, we'll just put something here to prop the door open, you put this ladder up, and she was like, it was super sketch. And so if you guys run into something super sketchy like that, like, you know, you can just be like, pull it up. I'm like, may not wanna do that. I would back out on something.
I'm just an intern.
Did they want to break
Someone
your legs
else.
or something?
She didn't do it, and ended up getting the safety manager involved and everything. It was a big deal. Like it was a sketchy deal.
Where was it at?
Like what? I don't know the building it was at or anything.
What company?
Yeah, that's
Our safety guy
Airco, maybe?
always calls our company.
He what?
Our safety guy always calls me our company's biggest insurance risk. Which is fair.
I need a PT chart.
Yeah.
There's like 8 of
Got
them.
him my wallet.
Those aren't good.
I actually need
Huh?
another. I lost mine.
That's how much
Gets the gauges out.
Good enough. Imagine having a PT chart in
Christmas break, whatever you want, just about to break out in the field. Thanksgiving break out in the field.
Yes. You have like 10
Have everyone said about pressures? We don't care about pressure, right?
Nope.
I mean, it's alright.
It's alright. That converted is 96 degrees. And then my suction pressure is 100, which is 32 degrees, red flag. Too low. And then my suction line temperature is 68 degrees.
It's got a TXV?
Fixed board, yeah, it doesn't even matter.
It's under. Wait, no.
Alright. Even if you figure out what it is, let's run through this real quick.
How much is 100 kids? Oh, 32.
My head, it's exactly 100 and 300.
Well, that's something you don't see every day.
So let's do condenser TD. It's 410A, so what should my condenser TD be?
30.
Nah,
20.
20. Every 410A machine is going to be 20. So, I should have a 40 degree condenser TD. I'm sorry, I should have a 20 degree condenser TD. 40? I know, I don't know where I counted that.
What is it, Struggle Street?
Struggle Street.
You're right above it.
It's 90 outside. What should my head pressure be? What should my condensing temperature be? 110. Everybody with me?
Yes.
90 outside, add 20 to it. As soon as I screw on that high side gauge, I'm looking for 110 degrees. What do we got?
100. Oh wait. 96. Let's see.
I got 96 degrees. Well, I don't have 110. I got 96. What can we say about the head pressure?
It's low.
Very good, class. So I just start marking it off over here. I've got low head pressure. And then I look at my suction pressure. Evaporator TD. What's my indoor temperature? 78. And we're just talking dry bulb now. So evaporator TD should be 30. So I just subtract 30 from that, which would be 48 degrees, right? So as soon as I know that the indoor temperature is 78, subtract 30, it should be 48 degrees. As soon as I hook up my low side gauge, I'm looking for 48 degrees. I got 32. What can we say about the suction pressure?
Low. Low suction.
Low head.
Low head.
Low
Low head, low suction. All right, now let's go back to the condenser again. What's my subcooling?
What did you say the temperature difference should be?
Evaporator TD is 30.
30. Figure it out.
Hey, not to be confused with evaporator split, where you just go return air, supply air, the difference. That should be around 20, 15 to 20. To be real honest with you guys, that's not a reading I take ever. I never take a split, ever, hardly ever. Ever. It really don't tell you much, man. It's an easy, like, crush. Like, this thing got an 18 degree split. No. It doesn't tell you much. It doesn't tell you anything about the latent removal, about the humidity removal. It just says, hey, this thing's pulling out. Mark my words. I'll make a bet with somebody. You can pull 25% of the charge out of a unit, and it'll still have a 15 to 20 degree split.
Go do it right now.
You're the man.
Because we're only looking at the sensible. Like, so that we no longer have a flooded evaporator, so it's not attacking the latent near as much. And but you could totally pull 25% of the charge out and still have a 15, 20 degree split most of the time. It'll still attack the sensible load, but you will not get any latent heat removal, no humidity removal. Not much at all. Alright, what do we say? Let's look at the condenser. What's my subcooling? High side converted and liquid line? 1. 96 minus 95. I have 1 degree. 1 degree of subcooling. What is subcooling? What's the definition of subcooling? Any heat removed from a liquid. So if I have low subcooling, how much liquid do I have? A little bit or a lot of bit? A little bit. So remember this. On subcooling, it's just a fuel gauge. Empty, full. Full would be like 20. Empty would be like 0. Right in the middle would be like 10. You guys see we're at 1. We're pretty empty. So is my condenser normal, starved, or flooded? Starved. Okay, I got low head, and I have a starved condenser. Where's my refrigerant at? Let's check the evaporator. 78 in the house. Evaporator TD should be 30. So I minus 30 off of that. I should have a 48 degree evaporator. Low suction? Oh, my bad, we already did that, huh? Let's do superheat. Suction line temperature minus low side converted.
36.
36 degrees of superheat.
That's a little much.
It's a lot of much. Alright, but on superheat is heat added to a vapor. So if I have a lot of superheat, I have a lot of vapor, I have a starved evaporator. Do you guys understand? Over here on your fuel gauge, on condenser, on subcooling, if I have a low subcooling, low liquid. But on the evaporator side, on the superheat side, it's reverse acting. If I have high superheat, it's starved. Low superheat is flooded, because we're talking about how much vapor is in the evaporator. Superheat is a fuel gauge of how much vapor. So if I have a lot of vapor, a lot of superheat, I have a starved evaporator. Is everybody cool with that? Subcooling and superheat are flip-flop. So low suction, starved evaporator. What's wrong with this unit? Low charge. You want another one? One more. Tomorrow I'm gonna hit you guys with a hard one.
So you said high superheat is starved?
Yes. Because a lot of superheat is a lot of vapor. Superheat is heat added to a vapor. So this fuel gauge over here. Huh? So what do we have, like 36 or whatever? This fuel gauge is reverse acting. High number is empty. On superheat, superheat is heat added to a vapor. If I have a lot of superheat, I have a lot of vapor, I'm starved. Y'all been sitting too long, huh?
Yeah.
Alright, let's go. Let's go get some tools.
Low subcooling would be starved?
Yes.
Okay.
High superheat is starved evaporator.
So if it's low and low, it's probably undercharged.
Right.
And high, over.
Yeah, flooded and flooded. Don't stop at condenser TD and evaporator TD. Like, you gotta do more than that.